Okay, you've probably asked an AI assistant a question and gotten this perfect right up to the minute answer. And you've got to admit, it feels kind of like magic, right? Well, it turns out behind that curtain, there's a surprisingly simple and really elegant conversation happening. So today, we're going to pull that curtain back and see exactly how an AI gets its superpowers. I mean, really think about it. You ask your AI, hey, what's the weather like in San Francisco today? It doesn't have a window. It can't feel the sun or the rain. So how does it know? How does it just pull that information out of thin air? That's the mystery we're going to solve right now. So here's the secret. Most AI models by themselves are kind of like a brilliant brain just sitting in a jar. I mean, they're incredibly powerful. They've been trained on just massive amounts of data. But, and this is the key, they're totally disconnected from the real live world. Their knowledge is basically frozen in time. They have no idea what happened 5 minutes ago, let alone what the weather is right now.
So to get a superpower, like, checking the weather or searching a database or even sending an email, the AI has to talk to another program that can actually do those things. It needs to have a conversation with an expert, and that's where the real magic happens.
Okay, to make this super clear, we're going to walk through a simple story. It's just a 4-step conversation between our two main characters. On one side, we have the AI. We'll call it the client. And on the other, we have the external weather app. Let's call that the server. All right, step 1. Every good conversation starts with an introduction, right? In the tech world, we call this the handshake. This is where the AI client reaches out to the weather server to say hello, make sure they're speaking the same language, and basically figure out, hey, what can we do together? And you can see how simple this is. It's basically the AI saying, hello, I'm an AI. I handle talking to the user. What can you do? And the weather server replies, welcome, I can get you the current weather. Oh, and by the way, I'll let you know if I learn any new tricks. Boom, just like that, they've established a connection and the basic rules of the game.
Okay, so they've shaken hands. Now what? Well, the AI needs to know its options. This is step 2, the menu phase. It's literally like walking into a restaurant and saying, can I see a menu, please? The AI needs a list of all the specific things, the tools, that the weather server can actually do. And the request is just that simple. Show me what you got. And the server comes back with this really clear, structured list. It gives a tool a name, weather current, and a simple description of what it does. This is so important because now the AI knows exactly what it can ask for and what to call it.
So now we're at step 3. The AI has the menu, so it's time to place an order. This is the tool execution step. It picks a specific tool right off that menu and gives the server all the information it needs to do its job. We call these arguments, things like the city and whether you want Fahrenheit or Celsius.
So the AI makes a really specific request. Hey, please use your weather current tool. The location is San Francisco and I need imperial units. The server goes off, does its thing, and comes back with a perfect, structured answer. The weather in San Francisco is 65 degrees and sunny, and that clean, simple data is exactly what the AI needs to turn around and give you a nice, normal-sounding answer. Okay, but here's the cool part. What happens if the weather server gets an upgrade? Let's say it adds a new tool, like a 5-day forecast. Does the AI have to keep asking if there's anything new? Nope. The server can actually send a message out of the blue to give the AI a heads up. We call this a notification. So the server just pings the AI and says, hey, just so you know, my list of tools has changed. That's the cue for the AI to say, oh, thanks, I'll ask for the new menu then. This is so much more efficient, right? It means the AI always has the latest info without having to constantly bother the server asking, anything new, anything new, anything new? So this whole 4-step dance we just watched, the handshake, the menu, the order, the update, it doesn't just happen randomly. It's all governed by a very specific set of rules, like a shared language that lets these two different programs talk to each other perfectly. So it's time we officially meet the protocol that makes all of this possible.
It's called the Model Context Protocol, or MCP for short, and you can just think of it as the official rulebook for the conversation. It's the thing that makes sure that both the AI client and the external server know exactly how to format their requests, their responses, and their notifications. It's what allows them to work together without any confusion. Now, MCP itself is broken down into 2 main parts. First, you've got the data layer. This is the language. It defines the actual words and grammar, the JSON RPC messages they're sending back and forth. Then you've got the transport layer. This is the phone line. It defines how those messages actually get from point A to point B, whether it's between 2 programs on the same computer or all the way across the internet. Okay, so now that we know the rules of the road, let's take a quick look at the core building blocks, the main players and what they can actually bring to the table. First up, the participants. You have the MCP host. Think of this as the main AI app, the general manager running the whole show. Then you have the MCP server. That's our expert, like the weather app, the one with the superpower. And finally, you have the MCP client, which is like a translator that manages one specific conversation. The really cool thing is, the host can manage a bunch of these translators at once, letting it talk to many different experts at the same time. So, what can one of these expert servers actually offer up? Well, it basically comes down to three main things. First, you've got tools. These are actual functions the AI can use, like a tool to send an email. Second, there are resources. Think of these as data sources, like the actual text inside of a file. And finally, you have prompts. These are reusable templates, like a pre-written system prompt for summarizing text. So it's like getting a toolbox, a library, and a cheat sheet all at once. Okay, so we've gone through some of the nitty-gritty details, but let's zoom out. Why does having a standard set of rules like this actually matter? What does this really mean for the future of AI? Honestly, having this standard rulebook is a complete game changer, and here's why. First, it makes AI capabilities dynamic. New tools can pop up or disappear whenever needed. It's incredibly efficient. No more wasting time constantly checking for updates. The server just tells you. It's consistent, which means all the different apps can speak the same language. And this is the big one. It's extensible. That means anyone can build a little server to give an AI a brand new skill. And that brings us to a really fascinating final thought. What this protocol does is create a true plug-and-play ecosystem for AI skills. We're not just talking about checking the weather or your calendar anymore. We're talking about a world where any app, any database, any service can give an AI a new superpower. So the real question isn't how it works anymore. The question is, what superpower will it learn next?